This one is October, November 2016, paper 4, variant 1. Question number 1. Is there any doubt in question 1? Any part of this question? Determine the distance fallen by the feather. So how you will work out, because it's a speed time graph, the acceleration is 1.6 and the time interval is 4.5. So using this, you have the formula A is equals to V minus U over T. A is the acceleration, which is 1.6. V is the speed. The final speed initially start with rest and the time interval is 4.5. So 4.5 multiplied by 1.6, that's equal to 7.2. So what does it mean? The final speed when the time interval is 4.5, that will be 7.2. So you will have 4.5 and 7.2 approximately a straight line because of constant acceleration, which is due to gravity. Then to find the distance, traveled, because it is making a triangle, so we'll use area of the triangle, and formula to calculate area of the triangle is half base multiplied by height. So the base in this question, the base is 4.5 and the height is 7.2. So it will be half or 1 by 2 base, which is 4.5 multiplied by 7.2. So that will give you the distance traveled by the object. Because for a speed time graph, the area under the graph will give us distance traveled by the object. The next part, why the graph, what will be the shape of the graph if the same feather is falling on Earth? Because Earth is having an atmosphere. So as Earth is having atmosphere, there is air resistance also, which is acting on the feather. So when air resistance balance with the weight, there is no resultant force. As there is no resultant force, it will move with a constant speed. We call that as terminal speed. That is why it will move or fall with a constant speed. Because for moon, there is no environment, atmosphere. That's why it will not have, or it will not reach the constant velocity or speed while falling. Question number 2. Is there any doubt in question 2? Question 2, part B. The tanker sail out onto a calm sea. The density of the sea water is greater than the density of the river water. State and explain any change in the depth of the bottom of the tanker below the surface. Like example, this is the surface of the this is the surface of the water or water level, and the same tanker is there in a river, and same size tanker is there in a sea. So pressure exerted by the liquid depends on the density, gravity, and depth. The density of the river water is smaller as compared to density of the sea water, which is higher density. So which one create a greater pressure? Or which one exert a greater pressure? Pressure exerted by the liquid. A sea water or a river water? So a sea water will apply a greater pressure. So as sea water will apply a greater pressure, A seawater will apply more greater upthrust or upward force as compared to a river water. So what will happen when we compare, because the question is state and explain any change in depth of the bottom of a tanker below the sea, means this distance. So in a river water, the greater part of a tanker will be underwater because it is applying smaller pressure as compared to that of seawater, which is having a high density, greater pressure. So it will have smaller depth, or to create a same pressure, it will have smaller depth. Is it clear? Question 2 part B. Or you can also use the term upthrust. Upthrust means the upward force exerted by the liquid, by the fluid, that is known as upthrust. Question 3. A closed container holds a quantity of a gas. Explain in terms of momentum how molecule of a gas exerted force on the wall. So how the molecule of a gas exerted force on the wall. So example, if a gas molecules are there inside a container, so these gas molecule hit the container. As these gas molecule hit the container, they bounce back. So they change the momentum. So gas molecules moving randomly change direction, which change the momentum. Because if the direction change, even though the speed remains same, but there will be a change in momentum because momentum is a vector quantity. Create force on unit area. So exert pressure. So basically what happened, as these gas molecules bounce off or bounce back, so there is a change in momentum. Whenever there is a change in momentum, there is always a force. And when there is a force on a unit area, what is there? There will be a pressure. So this is how, in terms of momentum, we can explain how these gas molecules are exerting pressure on the walls of container. In the next part, this is a manometer. From this figure, what we can work out, or what we can say, on the left hand side, the air is exerting pressure. On the right hand side, mercury is exerting pressure and the atmosphere is exerting pressure. So if I relate them by equation, what I can say, because if the levels are like it does not change anymore, it means the pressure from the right hand side is equals to pressure from the left hand side. So pressure from the left hand side is due to air, and pressure from a right hand side is due to mercury, liquid, plus pressure of atmosphere. So pressure of air is equals to pressure of liquid plus pressure of atmosphere. So in the question, the mercury traps a fixed mass of air in the left hand arm of the tube. The right hand arm of a tube is open to the atmosphere. The difference in the mercury level in the two arms is denoted by H. The pressure of the atmosphere on the surface of a mercury on the right hand arm is 760 millimeter, and the distance H is one. Pressure can also be, this is also representation of the pressure in terms of length. So pressure can also be denoted as millimeters of mercury. What is the meaning of millimeter of mercury? Actually, it is in terms of barometer, that you have a barometer is used to find that atmospheric pressure. So in a barometer, we have a container which is filled with mercury. and due to the surrounding pressure or pressure from the surrounding, that forces the mercury to rise in the tube. So as it forces the mercury to rise in the tube, so level of the mercury will increase in the tube, and this level, this is a length, like what is a, how much it increased. So this is a length example, 760 millimeter. So we can say the pressure due to atmosphere is 760 millimeter. 760 millimeter actually is representing that if this pressure is applied on the barometer, a mercury barometer, then it will cause the mercury to rise, or the difference in the level of mercury in a container and the tube will be 760 millimeter. So this is also a representation or a unit of pressure, which is 760 millimeter. So the atmospheric pressure is 760 millimeter and the distance h is 120 millimeter. Calculate the total pressure at level Q in millimeter of a mercury due to the pressure, due to the atmosphere and mercury above it. So above Q, there's a mercury, so there's a pressure due to mercury and there's a pressure due to atmosphere. So we can say at this point, there's a pressure due to mercury plus pressure due to atmosphere. Pressure of the mercury because of this height is 120 millimeters and pressure of the atmosphere is 760 millimeters. So when we add the two values, we will get 880 millimeters of mercury. Then the next part, they're saying calculate the pressure of the air trapped. So because the pressure of the atmosphere and mercury balances with the pressure exerted by the air, so left hand side pressure balances with the right hand side pressure. So if right hand side pressure is 880 millimeter, the left hand side pressure should also be 880 millimeter. So without showing any formula, you will directly write the answer, which is 880 millimeter. The initial volume of the air trapped in the left arm was 12 centimeter cube. So this is V1. The mercury poured into the right arm, the volume of the trapped air decreased, the temperature does not change, the difference become 240. Calculate the new volume. So basically we have to use a Boyle's law. According to Boyle's law, P1 V1 equals P2 V2. P1 is the first pressure. So when the volume, initially the volume was 12, the pressure was 880. Because the initial volume of air trapped in the left arm is 12 centimeter cube. So volume is 12 centimeter cube. The pressure was 880 as we work out. Then they add more mercury. So when they add more mercury, the level, this H now changes to 240. So now what is the new pressure? So what will be the new pressure? Already the atmosphere is exerting 760 and the height difference is 240. So the new pressure or the final pressure will become 880 of, because of atmosphere, plus due to the mercury level, that's 760 due to the atmosphere, plus 240, that is the mercury which we add, which is the sum will be 1000 and we are finding V2. So 880 multiplied by 12 equals 1000 multiplied by V2. 1000 is multiplied, other side it will divide. So 880 multiplied by 12 divided by 1000. That is equals to V2. Is it clear how we work out the value of V2? Why we are adding? Because the volume of the air at this point, initially it is 12 cm cube. That's the starting. And the pressure on this, as we work out the pressure on this was 120 and 760. So volume V1 is 12 and the pressure of the air or pressure on the air is 880. That is the first thing. But now what happened, as we add more mercury, so when we add more mercury, what we observe, we will observe, because the pressure increase, the volume will decrease. So new volume of the air, we don't know, that we are finding. But what about the pressure? So how to work out that pressure? That what is the new pressure on the air or of the air? So the difference in the level, is now 240. So 240 is the difference in the level or pressure due to mercury, and 760 is the pressure of atmosphere. So what is the new pressure experienced by this gas? That is again equal to pressure of the mercury plus pressure of atmosphere. So 240 plus 760, that is 1000. So P1, V1, when the pressure, when we are finding a relation between pressure and volume of a gas and temperature remain constant, so we use the Boyle's law, P1 V1 equal P2 V2. So initially the pressure was 880, the volume of the trapped air was 12, that they mentioned. The new pressure is 1000 because after adding 240 millimeter of mercury, and new volume we are finding, that's V2. Is it clear? Any doubt in question 4? Is there any doubt? Question 4. In question 4a, in an experiment, a cold water is poured into a bowl made up of insulating material. So insulating material means material which does not allow heat to escape. So we pour a liquid the container is placed in a draught-free room. So you don't have a moving air around which can cause too much. After several hours, the volume and the temperature were found to be decreased, like amount or the volume decreases as well as temperature also decrease. Name and describe the process that caused this decrease in volume. So why there is it, and explain why the temperature of the water also decreases. Basically, what is happening? The evaporation happened. And what happened in evaporation? How you explain the process? The most energetic molecules at the surface gain energy from the surrounding and escape. So as the most energetic molecule at the surface gain energy from the surrounding and escape, so the molecules which are left behind will have low energy. That is why it will cool down. So the process, that is evaporation. And what happened in evaporation? The most energetic molecules gain energy from surrounding and escape. So the molecules which left behind have low energy because their energy, some of their energy is taken by the molecules which are going out. The liquid will cool down, or we also say the temperature will decrease. So these molecules which are present at the surface, they are taking energy from the neighbors, even from outside as well as from the neighboring molecule, and they are going out only. So the molecules which are left behind will have low energy. That's how evaporation happen, and evaporation is also known as a cooling process. Any other question for? Question 5. In question 4, part C, in a third experiment, the same initial amount of cold water as is was poured in a metal bowl. The metal bowl is the same shape and size used in A. Compared to the experiment A, the decrease in temperature is less in the same time. So what is the reason for that? Because in the beginning, the initial experiment, you was having a bowl, and that bowl was made up of insulating material. Example, plastic or polystyrene. And the other one, it's made up of, this bowl is made up of insulator, and the other bowl is made up of conductor. So we have to same amount of liquid. Example, in the beginning, both liquids are also at same temperature. For example, this is at 10 degrees. This one is also at 10. After 5 minutes or after 3 minutes, evaporation is not a fast process or slow process. So example, after 3 minutes even, it will not have too much or considerable change. So after 15 minutes, example, which bowl will have a lower temperature? Evaporation is happening for both, but which bowl you think will have a lower temperature or liquid at lower temperature? Actually, what happened? The bowl which is made up of insulating material, that will show us greater change in temperature as compared to a bowl which is made up of metal. Reason for that is because insulator does not allow heat. Like example, when evaporation happen, evaporation cause the temperature change from 10 degree to 8 degree, because evaporation is a cooling process, so temperature will decrease. Here also the temperature decrease 2 degrees because the same rate of evaporation in the beginning. But what happened, because this is a conductor, so conductor can take energy from the surrounding, so it will allow the energy from the surrounding to transfer to the liquid. That's why the liquid temperature will increase slightly. That's why if you have a liquid which is inside, you have a liquid which is present in a container made up of metal and another made up of insulating material. So the container which is made up of metal will show a smaller change in temperature as compared to that of, because what conductor can do, conductor can transfer that energy from the surrounding to the liquid. But for insulator, this does not happen because insulator does not allow heat energy to pass through. That's why in insulator, there will be a greater change in temperature. And even that is mentioned in the question that compared to compare with the experiment in A, the decrease in temperature is less What is the reason for that? So conductors allow heat energy to pass, so they will take energy from surrounding and transfer to the liquid so that the liquid temperature might increase. Question 5. Any doubt in question 5? 5 part B. An ice hockey rink has an area of 1800 meters square. So example, this is a rink of ice hockey which is having a total area of 1800 meters square. The ice has a thickness so the thickness of this ice is 0.025 and the area is 1800 meters square. The density is 920. Calculate the mass. So formula which relate density, mass and volume. Density is equals to mass divided by volume. So if you need mass, that is density multiplied by volume. The density is 920 and the volume, because volume is area multiplied by height, so it will, the area is given 1800 multiplied by height thickness, that is 0.025. So when you multiply both of them, it will be 41,400 kilogram. Then the ice at zero, to form the ice, the water at zero is poured onto a floor of the ring and then frozen. The specific latent heat of fusion is 3.3 exponent 5. Calculate the energy removed. Whenever there is a change in state, you have the formula latent heat is equals to energy divided by mass. You need energy, so energy is equals to latent heat multiplied by mass. The latent heat is given 3.3 into 10 to the power 5 multiplied by what mass of ice you want. The total mass of the ice is 41,400. You will multiply them, you will get the energy required or energy removed, basically because here liquid is changing into solid, so energy will be removed, which is 1.4 exponent 10. And because it is energy, so that will be in joules. Question 6. Is there any doubt in question 6? Six part B. Sound waves in air have a wavelength of 22 millimeter. Figure 6.1 represent the wavefront. Wavefront means they are representing identical points. So if this is representing a successive crest. So this is crest, compression, 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 and compression. So what we have when we make a wave, first we have compression, rarefaction, then compression and rarefaction. So between the two successive compression, there should be a rarefaction. So we have to represent the rarefaction by a dotted line. So we will draw a dotted line. between the two successive compressions, and that will represent a rarefaction. Three rarefactions we have to draw. So this will be rarefaction, rarefaction, rarefaction. You can draw for the last one as well. That will be rare, because this is not the wave. These are the wave fronts which represent identical points of wave in different direction, or it can be in same direction. Use a figure. Use your value for the speed of a sound in A. Calculate the frequency. So what is the speed of sound in air? Typical speed 330, 340 you can take, it's up to you. And you have the wavelength which is 22. So the formula which you relate the frequency and the wavelength with speed. So V is equals to F lambda. V is the speed which is typical speed 330. F is the frequency we don't know. And the wavelength is 22 millimeter, but this should be in meter. So how to convert millimeter into meter? Divide by 1000. So this will be 0.022, and this is multiplied, other side it will divide, so frequency will be 330 divided by 0.022, which is 15,000 hertz. State in this we already did. The figure, draw a dotted line to represent the rarefactions. So between the two compressions, there will be a rarefaction. So you will just draw dotted line. Same thing between the two compressions, there will be rarefaction. In terms of both molecule and pressure, what is meant by a rarefaction? Rarefaction means the pressure is low and the molecules are away from each other. So region in the wave where the pressure is low and molecules are far away from each other. Question 7. Is there a doubt in question 7? Question 7 is related to completing a path for the ray. First, it will go straight because it is passing along the normal, then total internal reflection. Then we have to draw another prism so that we can explain how it emerge out or come out. It is passing along the normal, so it will pass straight. At this point, angle of incidence is more than critical, so it will undergo total internal reflection. This is how a periscope is able to reflect the light by using the idea of total internal reflection. And what happened in total internal reflection? We have to take two boxes. When you draw a path of a light, it should be you should represent an arrow as well, like show in which direction it is traveling. Select a statement that next condition to undergo total reflection, the angle of incidence should be greater than the critical, and speed of the light in glass is less than speed of light in air. So any other question or a part, if I miss any, you can mention. This was October, November 2016, paper 4, variant 1. Is there any doubt? Question 8. Calculate the energy transfer. So energy transfer is equals to power multiplied by time. This is a question we discussed yesterday. So energy is equals to power multiplied by time, and you can find the power, which is a product of VI and current is not known, so you can find the current voltage divided by resistance. So first voltage divided by this 8 cells multiplied by 1.5, that was 12. So 12 divided by 8, you'll get 1.5 ampere, and then you will find the power, which is 12 multiplied by 1.5, and after getting the power, or you will find the energy, which is power multiplied by time. So 18 multiplied by 40 multiplied by 60. I'll share another link and start a new topic and discuss some questions related to electrical circuits.